I'm going to start at the CSR's mandates, uh, which is around doing directed and multidisciplinary research. So we don't do blue sky research that belongs at the universities. Directed means we're problem focused, so we try always to understand what the challenge is in the manufacturing industry in our case, um, and then do work around those problems. We do technological innovation. Innovation for us means that we get involved in the implementation in industry. So it's not just academic work. And then we remind ourselves constantly that we have to act in the national interest. Um, and as you can see in the mandate, we have quite freedom on what fields we work in, who we partner with, and so on. And it's even in the mandate to contribute to the improvement of the quality of life of the people of the Republic. So this mandate has been around for a long time, and it is the driver in our daily activities and strategies that we develop and so on. So I think the best way to describe what we do in CSR is to look at our strategic objectives, which are published in our compact with the DSI every year. So it's a public document. So firstly, we conduct research and development of transformative technologies and accelerate the diffusion. And in our times, it's specifically the 4IR range of technologies, but it's beyond that. Then we improve the competitiveness of high impact industries to support South Africa's reindustrialization by collaborating, developing, localizing, and implementing technology in industry. And then the third one is to drive socio-economic transformation through RD&I that supports the development of a capable state. So there we work with different government departments, and we do a range of things with them, including studies to inform policy and development programs and so on. And the last two is more internally focused. So the one is to build and transform human capital and infrastructure. That human capital is very important. We are in a very dynamic talent market, lots of competition for talent from overseas. So it's important to build that human capital constantly. And some of the areas that we do R&D in is actually quite expensive in terms of infrastructure, and that could sometimes be a big constraint. And then just financial sustainability and good governance. So that's the big picture in CSR. We have in CSR 9 different clusters or units, and we are in the middle 3, our division. We look at manufacturing, and we've been given 4 specific industries to focus on, being automotive, medical devices, metals, aerospace, and then we also look at industrial equipment, machinery, that kind of thing. Hartmut will say a few words about mining, I hope, and then defense and security. But if you look at the other clusters, for example, the top middle chemicals, that's also manufacturing industry. Health has got to do with manufacturing, and so on. So I'm just going to focus on what we do in the manufacturing cluster. Just keep in mind that there's a broader picture. So if we look at what our contribution is, we could summarize it like this. We do materials engineering. So we develop new alloys and so on with special properties that's required in industry. Work with a number of companies doing that. We develop manufacturing process technologies, and those would be around shaping materials, fabrication, surface treatments, joining, and so on. And we do refurbishment technologies and systems. And I'll show you an example of that in a moment that actually combines a number of quite advanced technologies into one solution. Manufacturing equipment development. There, our main activity at the moment in terms of budget and number of specialists involved is in the metal additive manufacturing or metal 3D printing. We do a lot of custom-made one-off machines for companies that require special either manufacturing processes, assembly processes, or human materials handling and so on. And then we work in the space of manufacturing systems and industrial engineering. And when you look at that, it's another way of putting it is we optimize factories or what do you call it? Lines, manufacturing lines, production lines. And we do that with factory simulation tools. And we find and implement 4-hour-based competitiveness improvement opportunities with individual companies and with our target industries and industry bodies. Further areas of R&D, RD&I is in the product domain. So the factories, it's only a factory if it can produce something, obviously. So we work with companies to improve their products for export, for example, for meeting standards in the markets that they're targeting internationally. And we develop new products with companies, or sometimes we do it by ourselves, and we spin out companies around products and so on. We do product localization support, and that could be to take a product and to develop the manufacturing processes for that product, specifically for the processes available in the companies that's interested in manufacturing that product. We could redesign the product to make it easier to manufacture, and so on. This is typically in local content programs and so forth. We also bring in complete manufacturing processes. At the moment, we're working on a process that's called metal injection molding. It's been around for quite a while, but currently there's not any factory that we're aware of in South Africa that's actually implementing that manufacturing process. It's quite an involved process, and it's a bit high risk for companies to tackle. Then we do materials testing services and also forensics investigations, also product testing, etc. So here's just an example of work that we're doing at the moment with Eskom Rotec, which is the engineering arm of Eskom. As you know, we do maintenance on these big gas turbines, and the photo that you're looking at, if you look at the second and further on a ring of blades, you'll see it's got a ring there that keeps the blades in position. So one of the things that is done when the rotor is taken out for maintenance is those rings are inspected, and from time to time there's cracks in them. And in the past, what would happen is they would grind off the ends of all those blades to get the whole ring out. They would scrap all those blades, scrap the ring, and replace all of that with new blades and a new ring, and it takes forever. Now, with our technology, the machine that you see there in the background is a robotic arm um, with a tool which basically deposits metal powder on the blade tips. And then there's a laser feed that goes through that tool, and you have a metal uh, cladding um, functionality then. So you can grind off those tips from the blades um, and then rebuild them later on. So you don't have to replace the blade. Furthermore, we don't take the whole ring off, we just take the damaged part off, and then we can weld a new one into that area. Um, so that machine is developed by CSR with partners, mostly as a systems integrator. So we bought a commercial laser, a commercial robot, and so on. And we worked with the ESCOM R&D department for many years to develop that manufacturing process there to deposit the metal powders and melt it and they have the metallurgy sorted out so that on a metallurgical level you can't see a difference between the part that was cladded on and the original part. They have all of that certified, so we have a few welding engineers there in the photo. That's one of few in the country that's been working with ESCOM to make absolutely sure that this thing is going to work and keep on working. And it's actually better than what it was even before we started doing the maintenance. There's some additional functionality that we've worked on. For example, the leading edge of each of those turbine blades are high wear items and they wear off, and the whole thing becomes less efficient. Um, so cladding that leading edge is a program that we're working with ESCOM R&D to also get going. And then there's a technology for where the blades are mounted to the rotor itself. It's a high stress area and cracks typically form there. So we're working with them to sort of pre-stress that area using a laser technique. So this demonstration of us developing manufacturing processes, multiple ones, getting them certified and implemented, and helping to speed up the refurbishment and maintenance processes in ESCOM to reduce load shedding, obviously. So just that rotor that you're looking at, that's between half and one stage of load shedding. So obviously guys there are quite stressed and yeah, what can I say? So other areas for RDNI is similar to other organizations like ourselves in the rest of the world. NIST, for example, in the USA, and Fraunhofer in Germany. We get involved where there's infrastructure required for R&D or even for testing and so on that's beyond the means of individual companies, financial means, or where there's limited reason for a company to undertake R&D. For example, when they can't protect it in any way. If it's going to leak out easily, then they're reluctant, and that's where we sometimes step in. I talked about the metal injection molding, which is which has been around for a long time, actually, in the rest of the world. It's a technology with growing implementation. The whole powder metallurgy uh, business in the world grows much faster than other sectors in manufacturing. So to bring that technology in, built the first demonstration factory in South Africa, and then hopefully get local companies to invest and first try out on our facility, understand the risks, understand the economics, um, and then invest and get support from us to make it work in their own factories. That's the kind of thing that we're involved in. And then industry standards, especially in new areas, you tend to get a bunch of companies working in the same space, but using their own approaches and so on. And so the downstream industries then have this problem of um, not really knowing what they're getting from the different companies. So putting down a national kind of standard of doing the tech work for the development of that standard is another area of activity. Then we do industry level work with the industry bodies to help develop roadmaps and so on for the development of specific industries. We were involved, for example, a few years ago with a number of partners in the development of a roadmap for the aluminium industry. DSI has run a number of projects for developing roadmaps for different industry, including advanced manufacturing technologies and so on. Yeah, so we also, as I said earlier, do evidence-based policy development support, do all kinds of studies for that, and we contribute to the evaluation and design of development support measures. I'll give an example of that a little bit later. So I think one thing to keep in mind is that the manufacturing industry is extremely diverse. And so we find ourselves having to contribute on all the levels, you could say, from the really high-tech kind of advice and involvement right through to relatively basic manufacturing system support, quality management systems, and so on. So just as an example of that, in automotive in South Africa and internationally, we have a multi-tiered industry, largely controlled by the OEMs with enormous resources in terms of R&D and with significant influence over all the tiers in that industry. And in South Africa, they control basically what the tier 1 and tier 2 companies do. Not much needed from us there. Then the upstream industries, you have the smelters and so on, like metal, Hulamin. You have mining companies, and as we saw in the previous presentation, we talk billions of rands of investments, huge infrastructure, large companies, often with their own advanced in-house R&D capabilities and so on. Then the foundry industry, a little bit downstream from there, that's an industry that feeds many further industries. And it's a very interesting industry in terms of the mix of companies from high-tech, very advanced companies, medium-sized mostly, feeding into automotive, right through to family-owned small businesses with maybe 30, 40 employees that cannot afford R&D services, cannot pay normal professional rates. We have the multi-tiered industries. So in one industry, we end up having to support a broad range of needs, and then industry bodies, they need something different from us again. So this is just a explanation of the diversity of needs and services that we therefore need to have in place to support this manufacturing industries. So when we talk about small manufacturing businesses, creation and support, there, small businesses, as I said, can't really afford contract R&D services. So there we mostly providing support as part of national programs. One of them is the DTIC's Aerospace Industry Support Initiative, IEC. We've been involved in managing that for the department for many years. And there we are involved in independent objective manufacturing capability assessment for these small businesses. We identify capability gaps with them, given what their business objectives are. And then we do things like products and manufacturing capability roadmaps for them, so that they have a picture of what a good development path would be for them. And then we contract on their behalf companies that can provide those services, and that's those performance improvement services are then funded by the DTIC. So that is an example from the aerospace industry, which is one of these industries that we focus on in our cluster. Another one is the medical devices industry, and there we provide a range of services to small companies that I'll come to in a moment. Then we do product development and spin out. So one example of that is a technology for monitoring power lines, the big insulators that get dirty or cracks and so on, and to bring the line down. So it's a product that's manufactured by a spin out and sold internationally, used by Eskom as well. So product development and spin outs, one thing that we do. We help the companies, small existing companies, get access to supply chains. So supplier development, for example, in the OEM, in the automotive supply chain, upgrading manufacturing capabilities of small companies to the requirements of the whatever tier they are feeding into in the automotive industry, for example. We provide access to infrastructure and equipment for testing concepts, technologies, processes, and here also these days the sort of digital engineering infrastructure. So we have a full suite of engineering design tools, modeling and simulation tools in a number of engineering disciplines, and we again funded by the DTIC, provide access to that for small companies. And then we provide general advice and so on, often free of charge, ad hoc, just to help out, and especially around product development and product certification, especially for export. So just in terms of the medical device in this manufacturing industry support that we provide is probably too small for you to see, but there's a list of the kinds of things that we do. There's awareness training, there's device regulatory issues. Medical devices, you can imagine, there's very stringent regulations and standards needs to be complied with. Um, we help with product and manufacturing process development and the networking. So quality management systems, configuration management system, the device classification, um, the certification of the manufacturing system and the product in the end. The regulator support interfacing with the regulator and help small companies understand exactly what the implications of the regulations are and how to comply with them. Product testing, um, the product development according to the ISO standard 13485, which is a medical devices related standard. Config of the data pack. There's a lot of data management, and you could say secure data management that needs to be done for medical devices throughout the life of the medical device, and so on. So a host of services to small companies, and this is a program that we're doing with the TIA, and so far we've supported more than 80 small medical device entrepreneurs to get going. People have great ideas and completely underestimate what it takes to get a medical device through the certification and all the regulations that you have to comply with and what systems you need to have in place to operate in that industry. Sustainable development contributions. We work in the areas of metal recycling technologies. We, from time to time, work with towards finding alternative technologies, cleaner technologies, product technology and manufacturing process technologies for reducing environmental impact, and advice on implementing replacement technologies. This is an area that I think we need to grow. I think we're really in the early days of that. Waste stream beneficiation technologies. But for us, sustainable economic development obviously can only happen if we have competitive companies that are producing competitive products for export markets. And these days, this means you have to be competitive in all domains, including sustainability, green technologies, and so on, because of the requirements of the export markets that are more and more leaning in that direction. Then skills pipeline contribution quickly, largely for meeting our own needs. How do we grow R&D expert in key fields? So we have the usual things that I think most organizations of our size have in our training and development programs. And as I mentioned earlier, it's one of our big challenges, especially in engineering and the core space, the constant loss of expertise to overseas organizations. And yeah, the UAE is a special problem for us. So this is a big challenge. Broader contribution. So we're not an educational institution, but obviously we have an interest and an interest there. So we work with different organizations in that space that are delivering programs to students and so on. One of the things that we're doing is we're working with partners to create learning factories. And there we're involved with the partners to do curriculum development, especially focusing on scarce new skills that's required in the industries that we're targeting. We also look at new delivery methods, and for example, to provide remote access to manufacturing demonstration facilities for students to experiment with. So a student could, for example, not have direct access to some kind of a robot with a few tools and so on attached to it, maybe a few sensors, and we can provide access to the tools to program that robot, and then the student could download that code into the robot system and run it and observe via video link what the robot does. So that's an example, maybe not the best example, but of delivery methods for developing skills. Yeah, and then of course we make staff available to work with different institutions on different roles like lecturing, being external examiners, especially postgraduate academic supervisors and postgraduate project supervisors and so on. So just a few take-home points before Ahmed say a few words. So we provide a range of RDI services that cover most aspects of manufacturing, from materials right through to production systems. We provide national infrastructure for industrial development, including testing and certification support and technology demonstration support to reduce risk for the industry. We provide services for small companies, mostly through programs funded by the DTIC and the DSI. We think the NSI lacks mechanisms to foster industry cooperation towards competing internationally as a team South Africa. We end up competing nationally rather than competing as a team or as a nation for global market share. And that's, I think, something that needs to be looked at on a policy level. And then we need better mechanisms for achieving a sharper focus on industry needs, so that we are absolutely sure that the limited R&D funding that we have is spent on the things that will really make a difference in the country in terms of competitiveness and especially sustainability of competitiveness. And then I think you already mentioned by other speakers is this decrease in public funding means that we have to operate as business, and that means taking less risk, and that leads to all kinds of challenges, brings in a short-term focus, erosion of capabilities, and even if you work on simpler low-risk projects, you lose your experts because they want to work on challenging projects and advance their careers and want to work on routine projects. Okay, so in the mining space, we do testing of the ropes. We've been doing this for decades, and it's driven by regulations. So every one of the mines has to provide a rope to test. Also do some work at the Copper Boss facility for especially coal mines, the research around preventing explosions in coal mines. And we do competency-based training using 5R technologies to support zero harm. Then if you look broadly at the areas that we're involved in, ranges from extraction, mining processes, so mine planning, etc. We look at the geophysics, so during operations of the mines to figure out exactly where the ore body is, so that you mine optimally. We do rock engineering. This has to do also with making sure that any rock falls and so on are prevented and avoided, and that the right supports are put in, and the tunnels and so on are secured. And then we do digital and automation solutions. So we also do 4IR related work in the mines. digital modeling, digital twins, and so on. The digital transformation is also big in the mining space, like it is in manufacturing. And then we work in the environmental sustainability space. Yeah, it would have been better for my colleague to talk about this. What can I say? So a lot of testing on equipment, especially supports, as you can see there in the middle. Wooden supports and different types of supports. Also composite material-based supports to keep the roof up. We do training on self-rescuers. So if there is a rock fall and miners get trapped, there's a device that they use that provides them with oxygen and so on. So we are involved in the whole testing and maintaining of that device and the skills of people. It's quite a challenge to make sure that people will respond appropriately in a dangerous situation. You know, people sort of can go into freeze mode, and you need to make sure that your training prevents that. And then on the modernization side, a whole bunch of things that we're doing. Also, the Learning Factory as an application in that space. And then we're working with the large ground moving equipment, safety around that, and we've built a digital twin or a digital model of the whole operation of using these vehicles, trackers, mobile machines in the industry that we're working with a number of mines to get implemented. I think I've covered that. So how do we scale this? So in CSR, we develop products, prototypes, technologies, and so on. We do commercialization. We provide professional services similar to what we do in manufacturing, technical advice, technology demonstration, do programs, and so on. And we work with a bunch of mining houses as it is. You can see the list there. And those mining houses typically contact us directly for on these services. And when we talk about products, we have to work through the mining equipment manufacturing industry to get technologies implemented in mining. So that is what I'm able to say about mining. Thank you.